Good morning, friends. Just we discussed in the earlier lecture the failure of wave theory to explain the photoelectric effect. Right? So wave theory cannot explain the photoelectric effect. For that purpose, here the Einstein explained the photoelectric effect. In photoelectric effect, the frequency of the incident radiation must be greater than the threshold frequency. And as the intensity of the incident light increases, so photoelectric current is also going to increase. But the kinetic energy is not depends on intensity of photoelectron. As the frequency increases, so kinetic energy of the photoelectron increases. But the numbers of the photoelectron are not increases due to the increase in frequency of incident radiation. So this type of the photoelectric emission can be explained by the Einstein's explanation. So there is frequently asked in board exam 2 marks question. Explain the Einstein's explanation and obtain the Einstein's equation about photoelectric effect. Here the question is that explain Einstein's explanation of photoelectric effect and obtain Einstein's equation. So here in 1905, the Einstein proposed that not only the emission but the absorption of the energy that is known as the photon also take place in discrete unit. So in photoelectric emission, there is the photosensitive surface. As the incident radiation take place or the incident on the photosensitive surface, having the frequency M, so Einstein suggested that not only the emission but the absorption of energy is also take place in form of photon. Photon is the one type of the particle having the energy is equal to hf. F is the frequency of incident wave. So here this wave, in this wave, here the numbers of the photon are present. These photon are one by one incident on photosensitive surface, and this photon is absorbed by the photoelectron. That means the absorption of energy is also take place in discrete unit, like as the emission of the emission of energy. So that is the Einstein's observation about the photoelectric emission. Again, not only emission but absorption of energy, that is known as the photon, also take place in discrete unit. That means in a wave nature is there, but this wave is the bunch of photon having the bundle of energy is hf. Each and every photon has the energy is hf. Here, the energy of the wave is not continuously distributed. That is in form of a small packet having the energy is hf. When this energy is incident on the metal, so what's happened? This energy, bunch of energy is absorbed by the electron. When this energy is more than the required minimum energy to escape the energy, to escape the electron from the surface, that is known as the work function. In the beginning of this chapter, we define it. The minimum energy required to electron to escape from the surface of a metal is known as work function, and this work function is phi 0. According to the photoelectric effect, the frequency of incident radiation is minimum frequency f0. At that time, the work function phi 0 is equal to hf0. So that much minimum energy required to electron to escape from the surface of metal. Now, the wave having the frequencies greater than f0 is incident on a metallic surface. Therefore, the hf amount of energy is incident on the surface. So this energy is absorbed by the electron on the surface of metal. So out of this absorbed energy, HF0, that means this energy is utilized to escape the electron from the surface of the metal. And the remaining energy is given to the emitted electron in form of kinetic energy. In form of kinetic energy. Clear this? Therefore, the total energy is HF. Out of this HF energy, so phi 0 energy, that means the HF 0 energy is used to escape the electron from the surface, and remaining energy is given to the electron in form of kinetic energy. Therefore, kinetic energy is equal to HF minus phi 0. Clear? Okay. Now listen. Each quantum, that means the photon, has the energy is equal to HF. F is the frequency and H is the Planck's constant. Again, what is the photon? Photon is the bunch of energy having the bunch of energy HF. Where the F is the frequency of the radiation, electron on surface will absorb HF energy. If the energy absorbed by the electron is more than the minimum energy, that means the work function. Work function phi 0 is equal to HF 0. Then electron will be emitted with the maximum kinetic energy. Therefore, K maximum is equal to HF minus phi 0. Again, now in 1905, Einstein proposed that not only the emission but absorption of energy take place in discrete unit. And these units are known as the quantum or the photon of radiation. Now, each quantum or the photon has the energy is equal to HF. Where the F is the frequency of incident radiation. On surface, this energy is absorbed by the electron. If the energy absorbed by the electron is more than the minimum energy, that means the work function phi 0, then the electron will be emitted with the maximum kinetic energy. If energy of incident radiation is HF, maximum kinetic energy of electron is K maximum, and work function of metal is phi 0, then this relation is written as HF is equal to K maximum plus phi 0. Therefore, K maximum is equal to HF minus phi 0. That is the Einstein's equation about the photoelectric emission. K maximum is equal to HF minus phi 0. The maximum kinetic energy of electron emitted is determined by the form of photon, by the energy of photon. Just me, by the energy of photon. Again, the K maximum, that means the kinetic energy is equal to HF minus phi 0. HF is the energy incident on the metal. Phi 0 is the minimum work function required to emit the electron from the surface of a metal. The remaining energy is given to the emitted electron in form of kinetic energy. Therefore, the maximum kinetic energy of the electron emitted is determined by energy of photon. Okay. Now, but we know that the maximum kinetic energy is K maximum is equal to EV0. V0 is the stopping potential. Already we discussed in characteristic of photoelectric effect. Right? Okay. Therefore, K maximum is equal to EV0, where the V0 is the stopping potential. Now we substitute this value in our equation 1. Therefore, K maximum is equal to EV0. Therefore, EV0 is equal to HF minus phi 0. HF minus phi 0. As we do the graph of V0 versus the frequency of incident radiation, so this graph is straight line. Again, the graph of stopping potential, that means the energy versus frequency, is the straight line. the slope of this graph is h upon e. Keep in mind that here this sentence is frequently asked. The slope of V0 versus F graph or the energy versus frequency graph is h upon e. Clear this? Okay. So that is the 1 marks objective question frequently asked in board exam, good set, and also the NEET exam. The slope of the graph energy versus frequency is h upon e. So from this equation, here EV0 is equal to hf minus phi 0 divided each term by E. Therefore, V0 is equal to h upon E into f minus phi 0. Now here, we do the graph of V0 versus f. Phi 0 is the constant. This equation is similar to the equation of line y is equal to mx plus c. C is the constant, so here the phi 0 is constant, that is the minimum energy required to emit the electron. Therefore, the graph of y versus x, so m is the slope, so here the graph of V0 versus f, so h upon e is the slope. Phi 0 upon e is constant. Okay. For photoelectric emission, when the energy of incident radiation is much more than the minimum energy required, that means the work function, so kinetic energy, maximum kinetic energy is hf minus phi 0. Therefore, from this equation, phi 0 is equal to hf0. f0 is the threshold frequency. Therefore, value of the threshold frequency required is f0 is equal to phi 0 upon h. So from this equation, work function phi 0 is more. Therefore, frequency, that means the threshold frequency of minimum energy will be also more. Again, in this equation, for a given metal, if the work function is more, therefore, for this metal, the threshold frequency is also more. Thus, the intensity is not important for the photoelectric emission. Frequency is important, and frequency must be greater than the threshold frequency for photoelectric effect. That is Einstein's explanation. Again, what's happened here? If the energy incident radiation is hf, maximum kinetic energy of the electron is k maximum, and work function of metal, given metal, is phi 0. Therefore, the relation is hf is equal to k maximum plus phi 0. Therefore, k maximum is equal to hf minus phi 0. The maximum kinetic energy of emitted electron is determined by the energy of photon. Now, we know that, but the maximum kinetic energy is equal to EV0. We substitute in equation 1, therefore this equation becomes EV0 is equal to hf minus phi 0. Here the V0 is the stopping potential. Right? Yes, we do the graph of the stopping potential versus the frequency. So this graph is straight line, and the slope of this graph is h upon e. Now, for photoelectric emission, when the energy of incident radiation is greater than the work function, at that time the photoelectrons are emitted with the some kinetic energy, and therefore the kinetic energy is equal to hf minus phi 0. For minimum frequency required is, for that purpose, if you consider the kinetic energy is 0, therefore phi 0 is equal to hf 0. So therefore f0 is equal to phi 0 upon h. For a given metal, if the work function is more, therefore the value of the threshold frequency is more. Thus, Einstein suggested that the intensity of the light is not important for the photoelectric emission, but the frequency is important, and the frequency must be more than the threshold frequency. Clear this? So that is Einstein's explanation about the photoelectric emission. Now, just we discuss about the Einstein's explanation about the photoelectric effect. We derive the equation: the kinetic energy of the emitted photoelectrons is equal to incident energy of incident radiation minus the minimum frequency, minimum energy to emit the photoelectron. That means the wave function. That means the kinetic maximum kinetic energy is equal to hf minus phi 0 b derive this equation, and Einstein also explained that the frequency is important to produce the photoelectric effect. The intensity is not important. Any intense light can produce the photoelectric effect if the frequency of the incident radiation must be greater than the threshold frequency. Right? Okay. After that, now, why the photoelectric current is proportional to the intensity of incident radiation. As the intensity of the incident radiation increases, so how the numbers of the photoelectron emitted by the metal also increases. That means the photoelectric current is also increased. So here we are going to discuss and how this sentence is explained by the Einstein. Now, for that purpose, first, what is the intensity? What is the intensity of the light? That means the energy incident per unit area in unit time. That is known as the intensity of a light. That means the intensity I is equal to energy E per unit area, unit time. Keep in mind this equation. Frequently we are using numerical. Here, the intensity of a light is equal to total energy incident per unit area per unit time. That is known as the intensity. Okay. Now, according to Einstein's theory, intensity, that means the energy incident per unit area per unit time, is proportional to the quantum, that means the packet of energy. As the amount of energy incident in form of radiation is increases, therefore the intensity of the light is also going to increase. So that is the suggested by the Einstein. According to the Einstein's theory, intensity is proportional to the packet of energy. That means the quantum. When the energy of the incident is more number of the electrons will absorb the quantum energy. As a result, for F greater than F0, that means the for given radiation having the frequencies more than threshold frequency, more numbers of the electron will be emitted. So what it says that in a metallic surface, if the more intensive light is incident on a metallic surface, what's happened? The more number of the electron on the surface of the metal absorb the energy. Here condition is that the frequency is greater than F0. That means the frequency of the incident radiation is more than the threshold frequency. If the intensity is increases, therefore what's happened? HF amount of the energy is also more. Here more energy is incident, so more number of the electron absorb this energy. More number of the electron absorb the energy, therefore the more numbers of the electron will be emitted. Therefore the numbers of the photoelectron emitted from the surface of a metal is also more. Therefore the flow of current, that means the photoelectric current is also increase with increase in intensity of incident radiation. This fact explains for F is greater than F0. So, how the numbers of the electron emitted is more? For that purpose, we consider the radiation with the frequencies more than F0. How the photoelectric current proportional to the intensity of the radiation? According to Einstein, in photo effect, energy incident is absorbed by the electron. So Einstein suggested that in photoelectric effect, whatever the energy incident on a metallic surface, that is absorbed by the electron. Due to less intensity of the radiation, if the intensity of the radiation is less, the emission of the photoelectron is not delayed. So Einstein suggested that if the intensity of the radiation is less, so the photoelectric emission is not take place after the some time. There is the spontaneous or the instantly the photoelectrons are emitted. Because the elementary is absorption of the quantum of light. So Einstein suggested that if the less intense light is incident on in a metallic surface, so emission of the photoelectron is not delayed. That is the instantly the photoelectrons are emitted. Thus, the intensity determines the how many electrons will participate in photoelectric effect. So if the intensity is more, so more numbers of the electron absorb the energy, as a result the more electrons are emitted. If the intensity of the light is less, therefore the less number of the electron on the surface of a metal absorb the energy, but the emission of the photoelectron is spontaneous for the instant. So thus the Einstein explained the intensity or the numbers of the photoelectron emitted is depends on the intensity of the light. But here the condition is that the frequency of the light must be greater than the threshold frequency. Clear this? That is the explanation of the Einstein for the photoelectric current is depends on the intensity of light. Now the next question is there. The Millikan is name of the scientist. He want to disprove the Einstein's equation, but indirectly that gives the validity of Einstein's equation. That means the proves Einstein's equation. Again, the question is that in experiment aim to disprove the Einstein's equation, how Millikan proved Einstein's equation? Actually, the numbers of the experiment performed by the Millikan to disprove the Einstein's equation. But he obtained the value of Planck's constant by series of experiment. So this value is same and is equal to the given value of the Planck's constant 6.626 into 10⁻⁻34 joule into second. So he indirectly proved the Einstein's equation. For that purpose, Einstein's equation of the photoelectric effect is kinetic energy, maximum kinetic energy is equal to hf minus phi 0. And we know that according to the Einstein's equation, the maximum kinetic energy of the emitted photoelectron is equal to eV0. That means the half mv square maximum is equal to eV0, but the maximum kinetic energy is equal to hf minus phi 0. Here the V0 is the stopping potential. We substitute here. Therefore, eV0 is equal to hf minus phi 0. Therefore, if we substitute the value of kinetic energy, maximum kinetic energy as eV0, our equation becomes eV0 is equal to hf minus phi 0. Now, divided each term by the e, therefore V0 is equal to h upon e into f minus phi 0 upon e. Now, this equation is similar to the equation of a straight line, y is equal to mx plus c. Therefore, the slope of graph V0 versus f is a straight line and slope is h upon e. Now, the graph of the V0 versus f is straight line and slope is h upon e. In this figure, here the graph of stopping potential versus f is given according to the Einstein's explanation. Here the graph is straight line and s, here we do the slope. The slope of this graph is h upon e from this equation. Okay. Now, this intercept on frequency axis that represents the f0, that means the threshold frequency. Up to the threshold frequency, the kinetic energy of emitted photoelectron, actually no photoelectrons are emitted, therefore the stopping potential is 0. As the frequency is more than the threshold frequency, so stopping kinetic energy increases, therefore the stopping potential is also obtained. Okay. So Millikan made the series of experiment and obtained the value of slope. And from this slope, using the value of charge of an electron, is the charge of an electron, he obtained the value of as Planck's constant. He obtained 6.626 into 10⁻² minus 34 joule into second in each and every experiment. Again, the Millikan made the series of experiment and obtained the value of slope. Slope is h upon e. E is the charge of an electron. He used the value of charge of electron 1.6 into 10⁻² minus 19 coulomb and obtained the value of Planck's constant. Thus, each and every time he obtained the value of h is equal to slope into e. So each and every time he obtained the value of Planck's constant 6.626 into 10⁻² minus 34 joule into second is similar to the practical value of Planck's constant. Thus, in attempt to disprove Einstein's equation, the Millikan indirectly proved its validity. Right? That is only for understanding. Right? That is not important. How the Millikan also proved the Einstein's equation. Actually, here the most of the part of our answer is we directly take from the Einstein's explanation, the equation about the photoelectric effect, and what is the graph of the stopping potential versus frequency. This graph is straight line because this equation is similar to the equation of a straight line, and the slope of this graph is h upon e. From this slope, the Millikan performed the series of experiment, and using this concept h upon e is equal to slope, and in this equation he placed the value of charge of an electron 1.6 into 10⁻² minus 19 coulomb, and he obtained the value of h is 6.626 into 10⁻² minus 34 joule into second. Thus, in attempt to disprove the Einstein's equation, the Millikan indirectly proved its validity. Here this, so here the most of the part of the photoelectric effect is completed. Now after that we start our discussion about the characteristic of photon. Because already in the Einstein's explanation we considered that the bunch of energy, that means what are the radiation incident on a metal, is take place in form of bunch of energy or the packet of energy HF. And this bunch of energy is known as the photon or the quanta. Clear?